Let's look at this question. Finding the empirical formula from combustion data, IB November 2021. Student found this question really challenging, and we need to do some extra steps in this question in order to find the empirical formula. In order to find the empirical formula, what we need the mass of carbon, we need mass of hydrogen, and we need mass of oxygen. In this question, we have been given the mass of carbon dioxide and mass of water. And I have already highlighted the key informations we need to solve this question. So our compound contains carbon, hydrogen, and oxygen. So first thing we need to do is we need to find out the mass of carbon in that carbon dioxide sample. There's a 1 atom of carbon in carbon dioxide, and the molar mass of carbon atom is 12.01, and the molar mass of carbon dioxide is 44.01, and if I multiply that with 8.802, so I can find out the mass of carbon in that carbon dioxide sample. So if I solve this, that will give me 2.402 gram of carbon in that carbon dioxide sample. Similarly, I can find out the mass of hydrogen in water sample. So there are 2 hydrogen atoms, and the molar mass of each hydrogen atom is 1.01, and the molar mass of water is 18.02. If I multiply that with 3.604, and that will give me the mass of hydrogen. So if I solve this, that will come with 0.404 gram. So the last thing I need to do is to find out the mass of oxygen, because our compound contains carbon, hydrogen, and oxygen. So we have the mass of carbon, we have the mass of hydrogen, and we can find out the mass of oxygen by adding the mass of carbon and hydrogen and take away from the initial mass. So initial mass was 4.406, and if we add both the mass of carbon and hydrogen, that will give me 2.806. So if I solve that, I will have the mass of oxygen, which will be 1.600. So now I have the mass of carbon, mass of hydrogen, and mass of oxygen, and I can move to find out the empirical formula. So I'll write these masses here: 2.402, 0.404, and 1.600. So the first step is divide these masses with the molar masses, so to have the moles. So the molar mass of carbon is 12.01, molar mass of hydrogen is 1.01, and the molar mass of oxygen is 16.00. If I solve that, that will give me 0.2000, and that will give me 0.400, and that will give me 0.100. So next step is divide with the fewest mole. So the fewest moles is moles of oxygen. So if I divide everything with that, 0.1000, 0.1000, and 0.100. If I solve this, that will give me C2H4 and O. So this is the simplest whole number ratio. Sometimes empirical formula and molecular formula are the same, sometimes not. So let's move to the second part of the question. So we need to find the molecular formula. We have been given the molar mass. So in order to answer this part of the question, so I need to find out the empirical formula mass first. So I have 2 carbons in the empirical formula. So 2 times 12.02 plus I will have 1.01 times by 4 plus I will have 1 times 16.00. So if I solve that, that will give me 44.06. So if I divide the molar mass with the empirical formula mass, so the molar mass is 88.12 divided by 44.06, that will give me a factor of 2. So now if I multiply my empirical formula with 2, and that will give me the molecular formula. So it will be C4H8 and then O2.